Series and parallel circuits. In the top drawing of figure 3.7, there are two bulbs in series. That means that the current passes through one bulb and then the other. The same current is passing through the two bulbs. There will be a voltage across each bulb, and adding the two voltages will give the required battery voltage. Have a look at this diagram. Read that back through, pause it, give you an idea of what they're talking about. Top bulbs in series, bottom bulbs in parallel. So you can see how in the top bulb it's a series, and the bottom one you've got parallel. There you go. If bulb 1 is 3 volts at 0.5 amp and the bulb 2 is 6 volts, 0.5 amp, then a 9 volt battery, 3 volt and 6 volt will be needed and will supply a current of 0.5 amps. In the bottom drawing, the two bulbs are in parallel. Show that again. That means the same voltage is across both of them, and that it is also the required supply or battery voltage. If the two bulbs are identical, then the current drawn by each bulb would be the same. But that may not be the case. If bulb 1 is 12 volt, 0.5 amps, and bulb 2 is 12 volt, 1.1 amp, then they will require a 12 volt supply, and the total current drawn will be 1.5 amps. The current required is the sum of the currents through each bulb. That may apply in your Radio Shack. If you have an HF transmitter requiring 4 amps and a VHF transmitter drawing 3 amps, then running both will require 7 amps from your power supply. Remember the difference between series and parallel. For bulbs or resistors in series, the same current passes through each item, and the supply voltage is the sum of the individual voltages across each item. For bulbs or resistors in parallel, the same voltage is across all of them, and the total current is the sum of all the individual currents.